Alright, in the last series of this lecture on plotting using Octave, we will look at the example number 16 again, but then now we are taking the field F2. So as we have mentioned it before, F2 is a non-conservative field, but from the plot later we will see how this is so. Right, so let's plot this field force where the I component U is equals to Y and the V, which is the J component, is going to be equals to negative X. So let's go to the Octave. So as usual, we will define the linear space for X and the linear space for Y, the same for Z, and then we will again put the mesh field or the mesh points, and here we are going to define U equals to Y, V equals to minus X. Right, so basically this is what you see if you do not put a semicolon. So if you want to skip all these numbers, you can just put a semicolon over here, and then you will straight away get the command back. Right, so now we will want to plot. Here we have to use the quiver again, but now X, Y, Y, Z, Z is the usual because these are the mesh points. U is the I component, V is the J component, and the K component is equals to 0. So now if you press enter, you will have let's see, this kind of plot, which is a very nice kind of like a cylinder. But before that, we just put we just set the size and the font type, and we put the label for X, we put the label for Y, and the same for Z. Okay, so let's have a look at the plot. So this is my X axis, Y axis, and Z axis. So as you see, this is like a cylinder again. Now we want to rotate it. So let's just rotate it, and if you look at from the XY plane, you see this is kind of like a rotating fluid where this is the center, and then it rotates around it. Then let's just change our view a little bit. So this is YZ plane, YX, and if you turn it a little bit more, rotate it, and you have your XY plane. Okay, nothing nice from here because the vectors are along this plane, the XY plane. Okay, so here just to make sure that we see clearly, here if you look at the XY plane, you won't see any vectors coming out of this plane because basically the vectors are working on the XY plane. As you may have remembered, we do not have a K component over here, right? So that's why you don't see anything here. Okay, so now let's go and look at our question. It says you want to find the work done if you move an object from -1 to 1 1. So now I want to draw the point connecting -1 to 1 1. So I will go to here. I will use the command plot tree. So I use so this is my, over here this is my X. So this is the minimum, which is -1. This is the point that is going to go, which is 1. This is for the Y, which is -1 to 1, and Z, this is 0 to 0. Okay, so before I press enter, let's just put it hold on, and then we are going to plot 3, -1, right to 1, and this is the line which is given in green. So you can see a straight line over here. Let me just turn it a little bit, right? So you will see this point, -1 to 1 1. But I think this is more obvious if you look it from the XY plane. So this is the line. Right, and then what the equation says is that you move the object using a straight line which we have plotted, or you go from -1 through path 2, that is to this is x equals to 1, -1, and then you go up. So we will now plot 3. Now we go from let's see, we go from -1 to 1, which is moving along the x direction, but you make the y unchanged. So let's enter, and you have this point. It's not very obvious because the color is not in contrast. It is the one that is given by this horizontal blue line here. Okay, so next we want to have a point, we want to have a line that connects this point to this point. So what we do is, again, we use plot 3, -1, let's see. So we go from 1 to 1 in the x direction, there is no change, but we have a change in the y direction, which is -1 to 1. So let's enter this, and the line is given in red, as you may see here. So if you try to put this in the xz plane, you don't see anything, so because they are along this plane. Okay, so I think the best way to look at this is to see it from the xy plane. Okay, here if you notice, the first path, which is a path 1 here, right, this is the path 1. So path 1 is along this straight line. You go from here to here, and you will see when you are on the lower side here, when you move along this line, it will push you over to the left hand side. But when you are at the positive xy, then it's going to push you on the other end. So you just imagine you are walking along this side, you feel a force that push you towards the left, but then when you are on this side of the line, you have a field which pushes you to the right hand side. So you know, when you have a left and right, then it is going to counterbalance, and then you have work equals to 0. So this line will give you W equals to 0. Well, so now if you look at the path 2, we are going from this point to this point over here, and here you see is going opposite to the force field. So when you are going opposite to the force field, you are going to have a negative value for your work, right? Okay. Then you are going from here to here, and then again you have a negative value, right? Whereas if you use a path 3, which goes from here to here through a circle, okay, through a circle where your r is equals to square root of 2, because you have a 0, this is -1, -1, and you use the equation x squared plus y squared equals to r squared, and you have r equals to square root of 2. So you are moving along this semicircle, and since if you follow this line, it's going to go along the force field. So when it goes along the force field, your work is going to be positive. Okay, right, so basically that's how we understand the plot of the vector field, to understand the work done when you move an object from one place to another. So I hope this has been beneficial to you, and if you have any other questions, please feel free to post a message to me.